Clean code. Does it matter? Implementation Patterns is a book written by Kent Beck. This is a terrific book if you want to learn good coding habits. But in this book, Kent says that it's based on a fragile premise, that good code matters. Fragile? I don't think so. Let me tell you a story about the company killed by code. Long ago, in a company far away, I used a debugger that worked with C source code. It was made by a company named Sword Inc. It was powerful, and it saved us loads of time and effort. But it was 1990, and we were on the verge of changing from C to C++. Sword swore that they'd have a C++ version of the debugger coming soon. But time wore on. 6 months later, they shipped us a version of the debugger that took 45 minutes to load and then crashed. We threw it back to them with a stern warning. They promised that we'd have a new and better release soon. We were skeptical, but we waited. 6 months later, they sent us a new release. And what do you think? It took 45 minutes to load, and then it crashed. After that, we simply stopped counting on them. From our point of view, that product was dead. It was no surprise to any of us when, 6 months later, Sword went out of business. A decade later, I met someone who had worked at Sword back during those days, and he told me the story. He said, "We rushed that C debugger to market. We made a huge mess in the code. Later on, when we had to make it work with C++, well, it was just impossible to work through that mess." So, clean code certainly mattered to them. In the end, it was the bad code that killed that company. But what went wrong? What was it about all that messy code that killed them? Have you ever worked on a greenfield project? Do you remember how productive it was? Lightning would crackle from your fingertips as you got feature after feature working. You were going fast. Users would come to you and ask you for something new, and you could have it to them in a matter of hours or days. But the speed didn't last. A year or two later, things had slowed to a crawl. The harder and harder you worked, the slower and slower things seemed to go. And why? Because of the mess that had grown in the code. And slogging through that mess had really started to slow you down, and slow you down a lot. That high productivity you enjoyed at the beginning had now plummeted. Things that took you hours before took you days. Things that took you days before now take you weeks, months, or can't even be done at all. Managers grew concerned. After all, they had based their plans on your high productivity at the start. Now they faced a very scary gap in their business plans. The first strategy used by the managers to fill that gap was to put more pressure on the software developers. This served only to drive the developers to make even bigger and bigger messes, and despite heroic efforts, slow down even more. Next, managers tried to add more people to the team. This, of course, caused productivity to plummet as the new people sucked the life out of the old people. Then, eventually, the new people started working faster, making messes of their own, slowing everybody down even more. Adding manpower is not cheap. So now managers were faced with ever-increasing cost and ever-decreasing productivity. In desperation, they turned to the programmers and asked the programmers what they thought should be done. Of course, the developers knew exactly what to do. They'd been beating the redesign drums for months now. One of them said, "The best thing that could happen to this system is for us to walk into the machine room with a great big magnet. What this system needs is a major redesign." Managers were terrified of this option. They knew exactly how much this was going to cost, and they had no confidence at all that it would leave them in a better situation. But what else could they do? Reluctantly, they canceled any other plans they might have had, and they authorized a redesign for the whole project. For the developers, it was though a new day had dawned. We were going to do a greenfield project again. We could get away from the mess and be productive. Oh, happy day. So we picked the 10 best and brightest, the movers and shakers, the ones who would lead us away from the mess into the promised land of a new greenfield project. The rest of us hated those guys because customers weren't going to wait for the Tiger team to finish whatever they were doing. Customers needed bug fixes and new features, so we were left to slog through the mess while the Tiger team was off doing some greenfield thing. Meanwhile, the Tiger team needed requirements. And where do you think those requirements were? You think there was a requirements document? Even if there was, do you think it was accurate? No, there were too many last-minute fixes and midnight modifications for the requirements document to really mean anything. The real requirements for the new system were in the old system, in the old system's code. And so now the Tiger team was forced to slog through the code of the old system, trying to figure out what the requirements for the new system were. And so began a race, like Achilles and the tortoise in Zeno's paradox. Every time the Tiger team got to where the old system used to be, the old system had moved on with new fixes and new modifications. I've seen that race go on for 10 years. During those years, one by one, the members of the team were gradually replaced. The system became messier and messier, started getting twisted and warped. Eventually, even though it had never been deployed, the developers on the team started demanding a redesign. So that's how messy code can slow down a project, a department, a division, or even a company. But how? How does messy code drag productivity down so much? What are the mechanisms? What happens to code? Why does it go bad over time? It starts out clean, it starts out pretty, but then, with time, it starts to rot and stink like a piece of bad meat. You know how old this code is by looking at the facial expression of the software developers as they bring the code up on their screen. Before we look at why this happens, let's look at the symptoms. What is it about rotten code that slows us down? How does it affect our productivity? How does it affect our estimates? A rigid system is a system in which a single change or enhancement forces you to make dozens of changes throughout the body of the system. This happens because the code has gotten so tangled that any time you touch it in one place, you're forced to make adjustments in many other. And then you have to make even more adjustments in still other places. The programmers become like dogs, spinning around, chasing their tail throughout the code, making changes here, there, and there, and there, possibly touching hundreds of different modules just to get the system to work again. Rigid systems are very unpredictable. Estimating them is difficult because you never know how many modules will need to be changed. Fragile systems are systems that break in many places when you touch them in just one. A simple change to such a system can cause malfunctions all through the system. It's very difficult to estimate systems like this because they're so unpredictable. When a system is fragile, users and managers notice it. They see strange malfunctions in places that used to work, and those malfunctions make them very nervous. When developers make a change over here, but something over here breaks, nothing can be depended upon anymore. The developers appear to be incompetent, and the system appears to be unreliable.
An inseparable system is a system composed of modules that can't be separated and reused for other purposes. We try usually to make systems composed of modules that can be reused. Unfortunately, this effort often fails. System designers fail to enforce module boundaries. Software developers in a hurry take shortcuts. Those shortcuts often cross-couple modules, causing them to be inseparable and not reusable. Inseparable systems are unpredictable. You never know if you can reuse any of the components in the system, so you can't reliably make estimates. The folks behind these two doors are conducting code reviews. Take a moment to study this picture. It explains opacity better than my words could. Opaque code is code that does not communicate the author's intent. It's hard to read, hard to understand, and hard to change. Have you ever been significantly impeded by bad code? You're a software developer, of course you have. The question is, why did you write it? Was it because of stupid managers? Or impatient customers? Was it impossible schedules? Or maybe the requirements were changing too much? The reality is that those are all cop-outs. Those aren't the things that make code bad. What makes code bad is programmers. Programmers, us, we make the messes. It's our fault. We can't blame anyone else. We write the bad code. The reason we make the mess in the first place is because we feel the urgency of the customer, the pressure of the deadline. And so we rush. We tell ourselves that we'll go back and fix it later, but we know we won't. The irony of this is that it's the mess that slows us down. We can't go fast by making a mess. And you know this already. You've already admitted that you've been significantly impeded by bad code. If you want to go fast, you have to stay clean. The only way to go fast is to go well. This is hard to accept. Everybody thinks they can go faster by rushing, but that's an illusion. You can't rush through code and go fast. Some people think that, it's faster in the short term, but there's a long-term cost. But even that's an illusion. If you rush, it's going to hurt you in the short term and the long term. Clean code has no short-term cost, and you cannot go faster by rushing through code. Have you ever watched a sushi chef prepare sushi? It's a magical thing to watch. The next time you go, pay close attention. You'll see this guy moving quickly. His hands are a blur. He knows exactly where his knives are. He knows exactly where his food is. Every motion is well practiced. He's moving at light speed. It's magical. And then there's this moment where he takes this impeccably prepared food and he puts it in front of you. And if you look at his workspace, you'll notice that it's spotless. He's been cleaning the whole time he's been working because that's the only way that he can go fast. So, now we know how bad code slows us down. And we know that the only way to go fast is to go well. So what's clean code? What is clean code? I asked that question of several experts, so let's hear what they've got to say. Jarnis Trustrup, the inventor of C++, said, "I like my code to be elegant and efficient. Clean code does one thing. Elegant code is code that does a lot with just a few words. Efficient code is code that runs quickly with wasting few cycles. But what does it mean for code to do one thing? That's something we're going to talk about quite a bit in an upcoming episode." Grady Booch, the author of the 1990s classic Object-Oriented Design with Applications, said,
Clean code should be simple and direct. Clean code should read like well-written prose. We can all agree with the simple and direct part of that. But can code really read like well-written prose? The short answer to that is yes. The slightly longer answer is, well, almost. We're going to be talking about that in another episode soon. Michael Feathers, the author of Working Effectively with Legacy Code, said, "Clean code always looks like it was written by someone who cares." That's a lovely thought. We've all seen code that looks like nobody cares. This course is all about learning how to care for our code. Ward Cunningham, the inventor of wikis and so much more, said, "You know you are reading clean code when each routine that you read is pretty much what you expected." It's very much like Ward to use such innocuous words to say something so very profound. When is the last time you read code that was pretty much what you expected? And how can we learn to write code that is pretty much what our readers expect? That's what this course is about. Learning that kind of attention to detail, that kind of caring, that kind of way to be simple and direct. That's what clean code is all about. Robert Baden-Powell was the father of the Boy Scouts. As he died, he said to them, "Leave the world better than you found it." What if we did that with our code? What if we adopted the rule that said, check in your modules cleaner than you found them? Always do some random act of kindness to clean up your modules before you check them in. If everybody did that, the code would just get better and better and better. And that, too, is what this course is all about. So enough of all this fluffy talking about clean code. Let's actually get into some code. Let's get into episode 2. Thank you, dogs. There you go. Dogs.